I'm going to start with the formula for the capacitance of a coaxial cable. So this formula here. And I'm going to rearrange it to find the value of B in terms of all the other parameters. So B is the inner radius of the outer conductor. So to unpack this, because we have fractions on both sides and what the thing we want is in the denominator, I'm going to first start by multiplying both sides by the same denominator. And I'll do that so that we can eliminate the natural log, the thing that we want, from the denominator. So I'm going to multiply both sides by the natural log of a over b. So what that gives me is that. So I multiply the right-hand side, that cancels, and I end up with, on the right, just that product, and on the left, C over L, the capacitance per unit length, multiplied by the natural logarithm. The next thing we want to do, remember, the thing we're after is B. So everything that isn't B, we need to get rid of. So to get rid of the capacitance per unit length, we could divide both sides by C over L. That way, that would cancel with that. So that's my next step. I'm going to divide both sides by C over L. So I'm just going to write it here. I'm dividing by C over L. And here I'm multiplying by ln A over B. So that's what I'm doing for each step. So if you divide both sides by C over L, you'd expect this to disappear, and you'd end up with C over L in the denominator there. Next, remember, we're after B. So everything that isn't B, we want to get rid of, including the log. So how do you get rid of a log? We use something called an inverse log or an anti-log. The anti-log is basically whatever base you have to the power of this argument. So a natural log is a log to the base e. So when you have any natural logarithm, to get rid of the log and to find x in terms of y, the anti-log of a natural logarithm is e to the power y. So it's as if you're taking e to the power of both sides. So to reverse the log, we take the exponential. So x is e to the power y. So this is a general mathematical identity, and if you apply it here, this is the equivalent of your x. So a over b is e to the power all of that. So that gives me this expression here. So we're one step closer to finding B in terms of everything else. See, we've removed it from the denominator up to the numerator. We've got rid of the C over L. We've got rid of the natural log. Now all we need to do is bring it up to the numerator and then get rid of A. So bringing it up to the numerator, it's like taking the reciprocal of both sides. It's like flipping both sides. Right? Taking the reciprocal is like saying 1 over this equals 1 over that. So I want to flip both sides. Now, how do you flip something with a power? So the reciprocal of e to the x is e to the power negative x, because that's what the negative sign does. It has the effect of bringing something from the numerator up to the down to the denominator, or the other way around. So if I'm going to flip this and turn it into b over a, then I can flip the other side, and that becomes a negative, right? So that is where that came from. Okay, so that's that step. Now our final step, remember, we're looking for B. So what I want to do is now to get rid of A, and the easiest way to do that is to multiply both sides by A. And doing that will mean that that A will cancel with that A, and you end up with B equals A multiplied. So you're going to multiply this by A, so you can put the A right there, and that's your final expression. That is B in terms of everything else. Okay, so if the question had asked for A in terms of B, then we would have multiplied by B, and we would have had a B there, and that would have been our final answer. But we're trying to find B in terms of A, so there we have it. And I think the 2 pi's become a little bit messed up there, so there we have our 2 pi. So that's your final answer. Those are the steps to get there. I hope you found that helpful.